And with that, I would like to welcome Reza Rad to the Power BI Community Times in South Florida and virtual. Thank you, Reza, very much for your visit and to answer a very common question when it comes to connection types for Power BI, right? Many of you may know already Reza. He's a Power BI superstar. And Reza is also the CEO of Radacad. He's a Microsoft Regional Director, a trainer, an international speaker everywhere, author, blogger, and consultant. So he will tell us more about himself. And Reza, if you're ready and you want to start sharing your screen, and also tell us about Difinity, if you want to.
Yep, thank you. I appreciate that. Thank you for all the nice words, kind words. Let me share my slide. Now, where is this? Yep, here it is. Slide sharing, screen 1. And please let me know when you can see my screen.
Yes, I see your Power BI.
Yep, okay. So now you should see a slide. Okay, right. Great. Thank you for all the kind words. Thank you for everyone joining. Thank you, Cecilia, for hosting this event, organizing these events. Having these user groups all around the world is definitely helpful for everyone to get in touch with each other, learn about Power BI. So having people like Cecilia around is always definitely helpful. She is helping a lot of folks to connect to each other and learn from each other, which is good, especially that DA 100 study group. That looks fantastic. Awesome. Right. So in terms of this session, so this is the session about choosing the right type of connection in Power BI. Before I talk about that, about me based in New Zealand, it's a little bit further from the rest of the world. I'm a Power BI consultant and trainer. I have some books on Power BI. There are like 4 of them free. You can download from Radacad website. If you haven't done already, just go to Radacad website. You'll get like a notification that you can send your email, and then you'll receive those books. My contact information is also in the website. You can reach out to me, ask any questions you've got. And I have a lot of like free blogs and videos on YouTube and blogs in Radacad blog as well. So about this session, and anytime in the session, if you have any questions, feel free to interrupt me. I like this session to be more interactive than just me talking. So feel free anytime you have a question, just turn on your microphone, ask the question. So why this session? Why I come up with this idea? The thing is that in Power BI, we have more than just import data. But what the common knowledge is, people think that Power BI is just importing data, right? Power BI has more types of connection than import data, and each type of the connection has pros and cons. We cannot say like import data is the best or import data is the worst. Each of those come with some different pros and cons, which we are going to talk about it. And changing from one connection to another connection is not always like really straightforward, easy, which brings us to a really critical point that if you develop a solution with one type of connection, you may not be easily able to change it to another type of connection later on. So this is one of the decisions that you have to make early, at the early stages of deciding what your Power BI architecture should be. You have to also decide what type of connection you are going to use. Right, so because of that, I came up with this connection, with this kind of sessions. We are talking about these 4 types of connections in this session: import data, which is called scheduled refresh as well, DirectQuery live connection. There is a misconception. A lot of people think DirectQuery and live connection is the same. They are not. And composite mode. We'll talk about these, their pros and cons, and what scenarios you have to be using each. So the first one, which is the most popular one, is import data. This is the most popular because regardless of the data source, your data source can be anything, SQL Server, file, web page, anything, you can use import data on it anyway. This type of connection basically brings data into the storage engine of Power BI. Power BI has its own storage engine. It's an in-memory storage engine. That means it reads data from that source, it loads it into the memory in a compressed way. I'll talk about that a little bit more in next few slides. But when it brings it into that memory, because this is Power BI dataset, because this is the Power BI database engine, you can do anything with that. You can use Power Query to do any transformations you want. You can use DAX, write any calculations you want, full visualization. You are harnessing the full power of Power BI when you use import mode. On the other hand side, it's super fast because everything is stored in a memory. It's much faster to read from memory rather than reading it from, let's say, a text file or reading it from a database table. However, there is a big limitation. The limitation is the size of your model. If you are using Power BI Pro, you are limited to 1 GB per file, your dataset size. And if you are using Power BI Report Server, this is 2 GB. If you are using Premium, though, depends on the capacity you are using, you can go up to 400 GB, which can be quite big enough. Now, when I talk about that limitation of the size, a lot of time I get this question that, well, especially from database professionals, like, for example, I have a database table which is just 10 GB, just one table itself. So that means I cannot use this mode. That's not totally accurate because the way that Power BI populates that into the memory is a little bit different than just doing that exactly as is. Now, I'm not going into the deep conversation about how Power BI compressed the data, but just talking about it in very high level so that you can understand how this is working. Imagine we have a table like this, right? A table that has order ID, quarter, quantity, sales amount, date, some columns like this. And this is, let's say, a really big table. We have 100 million rows in this table, right? The way that traditional way of storing data worked was that we calculated like every one of these columns, how many bytes this take. For example, order ID is probably like an integer value. It might be 4 bytes. Quarter is an integer value, 4 bytes. Quantity, 4 bytes. Some of the more, some of them less. Then you can, based on that, calculate that each row, for example, might take 100 bytes, right? Just assumption. So 100 bytes a row. That means 100 bytes multiplied 100 million rows. You need 10 GB space for a table like this if you are using the traditional way of storing data. However, Power BI is not using that method. Power BI is using a method called column store technology. It's a little bit different. It's a little bit different than normal column store technology we are using in a normal database, but some parts of it is similar. What it does, it first order all the records. Let me get back here before talking about the order. The point for the column store is that if you have a column like quarter, for example, and if you have 100 million rows, you are storing that 100 million times. But how many values you have in your quarter column? You have just like 4 values, 1, 2, 3, 4. But you are storing that like 100 million times around. So another way to store it is to store it on a column level. That is why we call it column store technology. So first it sorts all the data, like all ones comes first, then all twos, all threes, all fours. It populate an index table like this. There are lots of terminologies. There are lots of details I'm skipping right now, just talking about high-level information. It has the quarter value itself, the start index, the end index. For example, quarter 1 starts from, let's say, index 1 all the way to whatever it is here. Then quarter 2 starts from here all the way to whatever is its ending. It stores all of that 100 million values into a table like this, 3 column, 4 rows, 12 values. We just have 12 values. Every value is an integer. So every value takes 4 bytes, 12, 4 bytes, 48 bytes is the total size of storing this column. Now, if we had stored this column in a traditional way, that would have been 4 bytes multiplied 100 million, 400 million bytes, 400 megabytes. From 400 megabytes, we ended up with 48 bytes. Doesn't mean that this is always the compression level. No, this highly depends on the cardinality of the values you are having. So I stopped the discussion about this compression because all I wanted to mention here is that when I talk about Power BI dataset is having like a size limitation, that 1 gigabyte is not the 1 gigabyte in the data source. Your data might be, let's say, 100 gigabyte, but when it comes to Power BI, it might be 100 megabytes, right? Or it might be more, it might be less. So always think about that memory size. So going further on the import data, when you use import data, you can import data from different sources. You can get data from CSV file, from Excel file. You are using Power BI in the most flexible way. And you can write measures, as I said. So pros and cons of this method is that it's fast. It's super fast because data is in memory. Everything happens on querying data from memory. And you have the full functions of Power BI. You can use DAX, fully functional, Power Query, and everything works perfectly. The downsides, however, is that if you have super large data set, something that doesn't fit in that memory size you are limited to, then you can't use this method. Another is that you have to always schedule your database to get fresh data. Otherwise, this doesn't really get updated. It's like a database that you import data in it, and then you don't have update information. So you have to schedule it to refresh, and your schedule refresh might be also limited by the license you use for Power BI. Power BI import data is something that a lot of us have seen. We just use Power BI, we connect to a data source, get data, and do the import, right? I'm not going to show you a demo of that. I'm going to show you a demo on other types of connections. The next type of connection is DirectQuery. DirectQuery is saying that we are not storing data in that in-memory storage because normally the data is like too much. That's one of the reasons. It's like too big data, petabytes of data, terabytes of data. We are not storing that into the memory. That's one reason. Another reason is that because I want the data fresh, live. Every time I want to query the data, I want to get it from the source. I don't want this process of like scheduling this to refresh. I can use DirectQuery. Now, DirectQuery is available only for a specific set of data sources. For example, you cannot have DirectQuery to an Excel file. You cannot have DirectQuery to a text CSV file. You can have DirectQuery to a database, like SQL Server database, to Oracle database. Different versions support differently, but most of the DirectQuery sources you see here, you can actually search for that in internet, like Power BI DirectQuery supported data sources. It will bring you a list of supported data sources that gets updated every few months. You'll see new items added to that. Okay, this doesn't mean that if you have these data sources, then you cannot use import. That was like one of the mistakes one of my clients have had in their like a misconception that they thought if they are using SQL Server as a data source, they have to use DirectQuery. No, that means with these sources, you have two options. You can either say import or you can say DirectQuery. Now, if you use DirectQuery, because there is no loading data into Power BI, things would work a little bit differently. You will not have a data tab in a DirectQuery mode. You will have just the report tab and the model tab. You can still see the relationships and things like that. Every query will be sent to the data source. For every visual you have, a query will be sent to the data source. I'll show you a demo of that. You can see that later. And that means for every visual, like for example, if I have a report page like this, this is how many visual? 1, 2, 3, 4, 5. 5 visuals. For every one of these, one query will be sent to the data source, like 5 queries. And that is only this view. For example, if I click on an item in a slicer, it will send another 5 queries to the data source. So DirectQuery is slow, super slow comparing it to import data. That is one of the important things you need to consider. And there are some, let's say, things you need to consider if you are using DirectQuery because you want good performance. Now, I'm not saying that everyone go and use this performance option I'm talking about here, but I'm mentioning this to tell you that there are things you need to consider when you are using DirectQuery. Here I have like 2 tables. They both are actually 48 million rows. So they are kind of considering it big tables, let's say. The first one just has a normal regular index on a table, like a normal database index, the primary key and the index provided by that. If we just select some of a value from that table, it takes 4 minutes and 4 seconds. This actually depends on the system, depends on the spec, but in, let's say, the same spec system, 4 minutes and 4 seconds to just return that. And something like this would be only like this visual, right? Imagine you have like 4 or 5 of these visuals. They are all sliced and diced by some other things, right? So if, for example, this takes 4 minutes to respond, each of these take 4 minutes, then I have to wait like 20 minutes for this report to show something to me, right? That's not acceptable, right? This is the same table, 48 million records, different table, let's say different design, which we have implemented some performance tuning. In this case, it was a column store clustered index. I'm not going to talk about database performance tuning. I'm not an expert on that. So don't ask me questions about how that is going to work, right? But imagine this is performance tuned. When I do the same query on this returns result in less than a second. Right? Same kind of things, less than a second. So you can imagine that if I am direct querying to this table, I would have far better performance rather than the first one, right? That is the critical point about direct query. If you are going to use direct query, you have to be sure that the performance of the data source is good. Otherwise, there is no point of using DirectQuery when it takes like 20 minutes for something to return. There's no point to do DirectQuery. So if you are using DirectQuery, make sure you either have a good performance tuning expert, like a DBA, like a database developer who can take care of that, or you should be going and learning that. It's not just Power BI knowledge that can help you with that. You should go and dig more into the performance of that. There are a few other things you can do on the Power BI side to make it a little bit better, but that is like after performance tuning of the data source. That is why I brought that first. So you have to be 100% sure that your database is performing the best way possible. Then you can do a few other things in Power BI. Like this is one of the useful things you can do in Power BI. It's under Power BI options, under query reduction. You can enable these 2 options, really helpful for the direct query. What they do, like when you have a slicer, normally by selecting an item in the slicer, everything else would be filtered, sliced and diced, right? That is the normal way that Power BI works. And that works perfectly well when we are in import data scenario. But then the problem is that what if you want to select like 5 items, right? Then you have to select the first one. It sends, let's say, 4 or 5 queries to the data source. Then you select the second one, 4 or 5 queries to the data source. Third one, 4 or 5 queries to the data source. You get the point? Like when I reach to the 5 item, I probably like sent 20 queries already to the data source, which I don't really need. What those couple of checkboxes are doing is that they add like a little apply button here, right? So you select your items and then you say apply. When you say apply, it sends the queries, right? It makes it better. Instead of 20 queries to the data source, you probably send like 4 queries, 5 queries, right? It's better, but still you need the database performance in place. Otherwise, still this would be slow. In DirectQuery, you are limited in both Power Query and DAX. you can do limited actions in Power Query, unlimited actions on DAX. Some of your transformations won't take place because they cannot be converted to like an MS script to a native query behind the scene. So you are limited on that stage. So before I talk about that pros and cons, let me just show you what the DirectQuery looks like. Here I can go and create a connection to my SQL Server local instance. And I'm using DirectQuery. Is that you can do that selection as you have seen. Yep, okay, so connecting to just one of these, let's say customer table, and I just select one more fact internet sales table, loading that data. So everything looks like a normal Power BI report so far. However, the difference is that the load when you are using DirectQuery is much faster because it is not actually loading data into in-memory database. There is no in-memory database structure in this case. The data is in the data source. At the bottom here, it tells me that the storage mode is DirectQuery, right? I can change it. If I click on it, I can change it to import mode. That will then bring everything to import, right? But the DirectQuery itself is just querying data from the data source. Then I can go to the model tab. I can see the relationship, but you see that there is no data tab. There used to be like a tab between these, a data tab that I could have seen the data. I could have make some calculations and things like that. Now you can do some calculations. It's not like fully limited. You can't do anything. You can do some calculations. You can do some Power Query transformations. You can do visualization. In terms of visualization, you are not really that much limited. It's just the data modeling and data transformation is limited part. And for everything you do here, there will be a query sent to the data source. Now here I have the SQL profiler. Not sure how many of you are coming from the database background. SQL profiler is a tool that we can use to track any queries sent to a SQL Server database, for example. Here I'm actually tracking my local SQL Server, right? For anything that comes from Power BI desktop. Right now I can go and start with getting a sales amount. You see that there is no query here. I'm actually monitoring it right now. As soon as I drag and drop the sales amount here, you see that this also takes a little bit of time. Now, this is really a small data. If it was a big data set, this would have taken much more. When I go to that there, I see the query sent to here, right? Now, like database professionals know many other ways to catch these queries, many other better ways. SQL Profiler is probably like one of the old ways I know from my old database development experience. But here it shows me the query, right? And anything I do there happens to be like the same. So if I say slice and dice this by a field from customer, like education, I see another query sent, right? It's not really beautiful query. It's like that. Select everything from here, then select everything from there, left join this one with that one, and things like that, right? But my point is that for every visual, you have this. For every interaction you do on the page, you have this. This will make the whole process slow. Your report would be slow. And of course, you are limited on the things that you can do, right? So I'll stop this. Back to the advantage and disadvantage. So then if Power Query is, if DirectQuery is slow, what is the point? The point is that you can have like unlimited size of data. You are not limited to anything as long as your data source can handle that size of data, petabytes, you can connect to it, right? You can connect to it, you can visualize it. However, it might be slow. So you need to consider that performance. That is one of the reasons that a lot of people use DirectQuery with some really powerful technologies behind the scene, like let's say Spark clusters and things like that behind the scene to make sure that that is performing really fast. You don't need to refresh data because every time it sends the query to the data source, every time you click on a visual, every time you click on a slicer, it's always the fresh data. These are advantages. However, disadvantages have only one data source. Power query limited, DAX limited, modeling limited. It's slow. Most of these disadvantages can be, however, cured with combining DirectQuery with import data, which is composite mode. I'll talk about that later. So far, these are pros and cons of that. As I said, if you have any questions, feel free to ask. Otherwise, I'll just continue. Okay, I guess no questions. So let's go ahead. Live connection. A lot of people think live connection and DirectQuery are the same because they both means the data stays in the data source. That's right, that they both means the data stays in the data source. We are not loading data into the in-memory storage of Power BI, but they are different. In some ways, they are different. Live connection is only possible to these 4 types of data sources. Only these. You cannot have a live connection to Oracle. That doesn't really make sense. You cannot have a live connection to, let's say, SAP HANA database. What you can connect to as a live connection is analysis services. Basically, this can be analysis services tabular or multidimensional. If this is, let's say, I think 2012 edition, Service Pack 1 or higher, but mainly to tabular edition, Azure Analysis Services, of course, and the Power BI dataset, because the Power BI dataset is also analysis services. So any of these can be considered as a live connection. Seems there's a question. VP Data Limited, what is the question? Feel free to turn on your microphone. No. Or you can just type it in the chat. Oh, yep.
Okay.
Here, something.
Thank you for the time. I just had a question. It's like I was wondering. See, the Vertipack engine could store data in a very efficient way, 10x time lesser than the data set. It's all fantastic. I just have a question in my mind, which is like, if we can store the data in memory, why don't we take the data and store it in a separate file kind of thing, a Microsoft file or something, the compressed data, so that we need not go through all this pain of connecting live and all this mixed connections and stuff, right? If you can layer, you pull the data, compress it, and put it, and you can increment load it, right? Later on the same data, so that you can create a kind of layered architecture over there.
You mean we persist that data somewhere that we can just add more rows into that, right?
Yes, absolutely.
So that is already happening, like analysis services, or let's say xVelocity behind the scene is working on a like data persistency technology. And when we do that incremental load, it is just adding data into that. But still, this is like in the memory, because like when the server starts, it loads that into the memory. It might be 100 megabyte. It loads into the memory. It might be like 10 gigabyte when it loads to the memory, or less or more.
I got that, Reza, but what I meant to ask is, see, we are compressing the data, we are increment loading it. Yeah, in memory, it's happening. Okay, but why don't we store that particular data, the compressed data, as a file?
Like as a CSV file, you mean something like that?
Kind of, yeah, some kind of format, some kind of Microsoft format, so that
you can read it from other places.
Yeah, for example, today I have 10 million rows. Vertipack, I connected. Yeah, it runs through all the 10 million rows, and it compresses and shows us the data in the front end, right? That's what's happening right now. Yeah, now it compresses the data, it picks up the data and stores it somewhere as a compressed file format.
Right.
Okay.
So what would be the point of that? You want to connect to it from another tool, or why do you want to store it? Let's say.
you can build an architecture. Imagine you have order table, transaction table, and two lookup tables. Okay. Today, I load these three tables and build a report with it. It's already in memory. Okay. And tomorrow I have more 10,000 rows. Okay. Now, when I try to connect it, it might be more than the 10 GB of data capacity, right? Okay. So in the first instance, when I load the first 10 million rows, it takes the data, it compresses it, it saves it in a different file format. Okay, so that I connect it to that file format, and it will happen. It will keep on updating on that file format, so that it's in your server or it's in your computer. You need not depend on the cloud or anything, right? You can build the architecture. I think that's how I think Click works in that way. They call it as something like QVD or something like that.
You can use like some data transform technologies for that. Like we've got obviously data flows that works with the file format and can store it in a file format, and you can have incremental load that look into the file format, but still that is not the format that the analysis services like work with. Analysis services has to still expand it, store it in a different format in that in-memory structure. I still don't understand what would be the help if that analysis services would have been saved as a file separately, because still this, for like all the incremental refresh and things like that, this is already supporting that infrastructure for you.
Yeah, but it's still not suffixing my need of always connecting it to the in memory thing. It's if my data is more than 10 GB, I have to again buy a license or something. I mean, I have to pay more to get more. So when it comes to, if it's a if it's a small thing which I want to make, Power BI is excellent. I would completely agree with that. It's fast, it's excellent, it's easy, it's intuitive. But when it comes to scaling up, this is a big issue actually. It's 10 GB and the cost goes high, and which I could do it in Click, very easy. It's just save it as a QVD and pull it from that and increment load it. So yes, but a learning curve, and it's very tough to use.
Yeah,
I don't like that perspective, but
I guess when I talk about the composite model, that will clear up some of the stuff. Like if you have limitation on the size, you can have part of things DirectQuery, part of things imported, that would still give you like a super fast performance. And you can still have your large data, and you won't be limited to the size that you've got. I believe like that in Click, in Tableau, in other tools, there might be other ways of doing it. This is, let's say, the Power BI ways of doing it, but it doesn't mean that Power BI can't handle large data. It can definitely handle that. I'll show you like an example of how this can be done a little bit later when we talk about composite model.
Fantastic. I'll wait for that, Reza. Thank you. Thanks for considering my request. Thank you.
You're welcome. Right. Okay. So back to the live connection. So the live connection is the connection you can have to analysis services. As I said, Power BI Dataset is also an analysis services that you can connect to that. Now, when we have live connection, there's a big difference. Power BI or analysis services, these are basically modeling engines. These are engines that we have like a storage in it, we have data stored in it, we have tables, we have the relationships, we have calculations. So when you connect to that using a live connection, you have access to everything in that model. You kind of connect to that model, you grab everything from there. You don't need to go and rebuild some of the calculations. In most of the cases that we use live connection, or live connection source is already a defined model with all the things that we need in it. We just go and do the visualization in these cases. This will still send query to the data source. This would be, however, like a different type of query. It's not SQL query. It would be like DAX or MDX query and things like that, but it still would be queries to the data source. You are limited on the modeling side. You cannot use Power Query. You cannot use modeling. This This slide particularly, and one other I'm going to talk about a little bit later, might change in the next few months because one of the features is implementing for Power BI data for Power BI Live connection to be able to connect to multiple live connection at the same time. Not available right now, but it's coming very soon. So then if that become available, then these two probably would be partially available. We have to see how that is going to be implemented. Using Power BI with live connection is one of the really common usage of enterprise Power BI. Because in enterprise implementation of Power BI, normally we have a data warehouse, we have an ETL system grabbing data, loading it into that data warehouse, can be SSIS, Azure Data Factory. Then we have a data model built in analysis services. It can be Azure Analysis Services or on-prem. And depends on if it is on-prem, we might have a gateway, then Power BI connection to that with a live connection and visualizing the data. This is one of the really common way of using Power BI. It brings governance around it. It means that your users are doing visualization. They are not doing the data modeling. Only those who are data modelers will be doing data modeling. So one way to control how Power BI elements works and Power BI components works is to use this type of connection. Although you cannot do modeling, however, you can create a specific type of calculation called report level measure. Report level measure is basically a calculation you write in your report. It's just in your report. It's not going to be back into the model. Just belong to your report. That is why we call it report level measure. If someone else connect to that model, they will not have that measure because this is a measure only in this report, right? So it's kind of good for sometimes doing some self-service things, but as soon as you find a measure that is going to be used probably across the model for many other users, then better to have it back into the actual main model. Live connection can be also connected to the Power BI dataset, and that is something that can be used quite frequently. You can build a Power BI dataset separately, connect to it from a Power BI visualization. That is one of the ways that I normally explain in my Power BI data flows versus dataset session that I explain. Create a shared dataset and use it somewhere else, because this will give you a separation of the visualization layer and the modeling layer. So let me show you an example of this before talking about pros and cons of this. So I'm opening another Power BI report this time, and I'm just showing you a live connection to another Power BI dataset. I'm not showing you the analysis services. It's kind of the same. I'm connecting to a Power BI dataset because that is also considered as like a live connection. And I choose one of the data sets that I have created before. I connect to this data set. Now, when I create this type of connection, down at the bottom here, you see that it says connected live to the Power BI dataset. That is the location of that dataset. I see the tables. They come with their calculations. Some of these might be calculations, but I don't need to know how those calculations have been created. I can go and visualize these information in any ways I want, right? Like this is sales by studio, and we'll change it to donut chart because that's something a lot of people like. So basically you can do your visualization connected to the Power BI, but as you see at the top, my Power Query is kind of limited. I cannot connect to another data source, although this is coming very soon. It's supposed to be actually this October, but tomorrow my time is end of October, I think 2 days for you. So I guess it is coming a little bit further. But wait for that. That is one of the biggest changes coming in Power BI, the ability to have connection to multiple live connections. Apart from that, this is pure Power BI visualization. This helps you really good to have your visualization layer totally separated from the rest of your model. One of the really good architectural advice I normally give to people is to do this kind of implementation as part of their implementation, not to go and use live connection all of the time, but like use it partially. What are pros and cons of this type of connection? So pros, it's faster than DirectQuery. Now, why this is faster? Normally because analysis services works on an engine that normally is faster. If it is like back analysis services multidimensional, it might not be, let's say, that much faster. But still that works on a file-based system, so it might be a little bit faster than a normal database. If it is analysis services tabular, that is basically using in-memory technology, so it is fast. You can have full power of DAX calculations and things like that in the actual model, I'd say, because here in the Power BI, if you create a report level measure, that won't be, let's say, so much point except for some self-service things. The main thing is to do that in the model. You have, on the other hand side, some disadvantages, because building like an architecture around that means that you have separate layers. You have a visualization layer, you have a modeling layer. You have to have more like a development life cycle rather than just import data. Oops, sorry, just import data, do everything here. So it's a little bit different. It's a more like enterprise approach of using it for more bigger teams. If I have like a team of one developer, one person doing everything in Power BI, I probably might not do it this way. Now, composite mode, which goes back to the question we had earlier, that what if I'm limited on the size? What if I have a big data? So I'm limited on the size. I have big data. That means I cannot use import. I must have use DirectQuery, but if I use DirectQuery, everything is slow, everything is limited. What can I do? Composite mode is a mode that introduced like about a couple of years ago, almost a couple of years ago. We had this concept of the import brings the query performance. Everything is super fast. DirectQuery gives us the ability to have big data models and the freshness of data. Every time you query the data, you get the up-to-date information. So the whole concept of composite model is to combine these together, have DirectQuery import in one place, have the query performance, data freshness, big model, everything in one. How that is going to work? Imagine when you are building a data model, if we talk about import or DirectQuery, that means in the import scenario, I load everything into the memory. Right? Some of these tables are small, some of these tables are big. For example, geography table might not be big, but the sales table might be, or reseller sales table might be. If I import it, I'm importing the small tables as well as big and huge tables. Same thing for DirectQuery. If I'm connecting to these DirectQuery, some of these are big, sales, reseller sales, which makes sense. Some of these are small, like geography. Why should I keep that imported? Why should I keep that as a DirectQuery? The concept of composite mode is to keep part of these tables import, part of them DirectQuery, right? You see that some of these tables can be DirectQuery. Some of them, those smaller one, can be imported, right? So if we go back to, for example, just an example model like this, here I have a sales table. This is a popular AdventureWorks dataset. I have a sales table here. I have some dimensions around it. It's not a really full star schema design. You see some dimensions are filtered by other dimensions, but let's not worry about that at the moment. Let's assume my fact table is like billions of rows. This is the huge table. Everything else is probably like really small. This is the biggest one, right? When we have a Power BI report visualization on a DirectQuery mode, this becomes slow because for every one of these visuals, it sends a query to the data source, right? If I have like this much visualization, this is like 6 queries to the data source. Now, the point is that most of those queries are not really querying data at every data row level. They are querying this data in an aggregation level. Like, for example, a visual like this. Am I looking at every single data row to visualize this? No, I'm aggregating data. This is the sales value by the calendar year. I'm aggregating data by the year. So I'm actually, like, my select statement to the database would be select sum of sales group by the year, right? Something like that. Now, if I'm doing something like that, then I'm not really looking at every single row. I can have this aggregated data stored and then query data from there. So that means that I can have an aggregated table stored in memory, while my actual table, the big table, how many rows it is, doesn't matter, is sitting in the data source. And that is already using DirectQuery. I can have an aggregated version of that in memory, right? Composite model works with the concept of aggregated tables. Then a visual like this doesn't need to go all the way to the data source to return the result. It can just be resolved with querying data from this. And because this is in memory, this is fast. Because this is just a small table, like aggregated by year, how many rows you expect this to be? Like, for example, 5 rows, 10 rows, 20 rows if you have 20 years of data, right? So this would be really a small table. It's like nothing compared to that big size, and you can load it in memory easily. In this concept of composite mode, you can have some of the tables using DirectQuery. You can have some of the tables imported, your aggregated tables usually imported. We have a specific storage mode called dual. I'm not going to talk about the details of how to implement a composite model. That is like a separate thing. I have some videos on that on YouTube. Go and check, go and search for composite model aggregation. You'll find some of those videos. I'm not going to talk about that, but basically dual is kind of both import data and DirectQuery at the same time. If I use it with a DirectQuery table, it acts like a DirectQuery. If I use it with the import data, it acts like import data, right? And I can have multiple layers of aggregation. For example, a visual like this might be good for this with this aggregated table, but if I bring, let's say, a customer as a legend to that, that might not work. Then I might have like another aggregation. You can have like layers of aggregation, and this can work like fast on terabytes of data, petabytes of data. We have some examples, videos in YouTube. You can go and watch. Christian Wade has a really good example of that, working like with petabytes of data. That it's just like drag and drop. Everything is super fast. How that works, of course, with the concept of aggregation, the data, the visual queries the first aggregated table. If it doesn't, it queries the second. If it doesn't, it queries to the actual data source. So this way, I can kind of have my aggregated table in the limit that I have based on my Power BI, let's say, license limitation, size limitation, whatever it is. But I can have still my big data, and everything works in a really good way. Let me show you an example of that. Now, this example I'm going to show you is not really a big data, but it is a composite model. So you'll get the feeling of how that works behind the scene. I'm going to use the SQL profiler for this as well. Okay, so let's clear this and run the SQL profiler again. Okay, now let me show you how this model works. So you see here, I have a bunch of tables. Some of these tables are import, some of them are DirectQuery. In fact, when I hover on it, you should see that they are a little bit different. You see that fact internet sales is DirectQuery, the storage mode. Promotion is DirectQuery. Some of the tables might not be, like product table is DirectQuery, but product category table is dual storage mode. That means I have a version of that in memory as well, and it is also in DirectQuery. Some of the tables can be only imported. If I go to the model, a little bit better view of the model if I can find. Yeah, here it is. Like this table is imported table. I have that table hidden. But if I go there and if I can see what is the storage mode of this is? Doesn't show it to me here, but if I go to this tab, it shows me the storage mode. Yeah, here you can see. This is the import. So I have actually an aggregated table behind the scene that whenever I go and look at that table, the data of that is imported, right? So that is the table. Now, let's not worry about all of this. Let's come back to the visualization side. I'll make sure that here everything is clear and we are watching this. Now, fact internet sales is my direct query table. Imagine this is huge. Imagine this is terabytes of data. Because it can be petabytes of data, anything you want. You are not loading that data into Power BI, so this can be any size you want. I'll go and grab the sales amount right into my page. Based on what you have seen from the direct query example I showed you before, this means that this should send a query to the data source, right? It acted really fast. When I go to the SQL profiler, no SQL query sent to the data source. How that is possible? Because Power BI knows that there is an aggregated table behind the scene. Even if I get data from this knows that there is an aggregated table behind the scene. That aggregated table is aggregated sales by some other factors. So as long as I'm playing within those columns, those aggregation levels, everything would be fine. Everything would be queried from the imported data. Like, for example, one of the things is in that aggregated table is by the date. So if I bring calendar year in the axis, still this is fast, still no query to the data source. This is an audit log. This is not really a query to the data source, right? So nothing sends to the data source. But what happens if I bring something, if I slice and dice this by something which is not in my aggregated table, like for example, slice and dice this by something from promotion table in this case, then it will send a query to the data source, right? You see that query sent to the data source. This is getting data based on promotion and some of the sales. So the query sent to the data source because my aggregated table behind the scene, going back to that, this is my aggregated table. This is by date, by customer, by product category, but it's not by promotion, right? Because that was something that was not considered in my aggregated view. So that goes as a direct query. Can I make it better? Of course, I can define another aggregated table. Right now, this model is just with one aggregated table. I can have another aggregated table that is by all of these and promotion, another that is by something else. You can have like layers of aggregation. The whole point about aggregation and composite model is to make it multiple layer. That is where you get the best of this. But the fact is that when you use this method, then your options are kind of unlimited. You can have like huge size of data. You can have visualizations that fast, and you can have your DAX calculations, and everything works really perfect, even with the big size of the data. Oh, sorry, wrong slide. So just a quick wrap up of this, and then we'll do a question. So choosing the right method of time. Yep.
Oh, so Gina wanted to see again the composite model view for the model you were showing.
Oh, was that Gina? Could we see model view with relationship? Yep. Okay. Yep. Definitely. You mean this? It's a little bit clumsy view, but let me see if I can make it a little bit better. So this is the aggregated table. I'll make it a little bit bigger. These are dimensions around. This is the actual fact table. So this is the big fact table. And that is the aggregated table. The aggregated table, as you see, is connected to some of the dimensions that the fact table is also connected, but fact table is also connected to some dimensions that the aggregated table is not, because that is only aggregated at a certain level, not everything. Okay, sounds good. Right. I'll get to your question, Aaron, and Anand, I guess. But let me first wrap up this whole section and then we'll talk about those. So choosing the right method of connection among these, what would be the best method of connection? You have seen pros and cons of each, so kind of can kind of guess what these different scenarios would work. If you want something to perform really fast, you need to look at import data. You need to look at composite mode because that is also using import data partially. You can use live connection as well. That is kind of an import data behind the scene. DirectQuery should be like at the bottom of the list when you are talking about the fast. However, if you use DirectQuery in a composite way, then that is going to be fast, like what you have seen already. Which method is more flexible? Of course, import data is the most flexible option. However, the problem that comes with it is that everyone starts to build their own model. Like in a large organization with, let's say, 1,000 employees, you give them the ability to do import data. Then everyone goes and builds their own data model. You end up with like tons of silos of data models, data visualizations, data analysis. So you should be careful of how you are going to implement self-service. I'm not saying that self-service is bad. Self-service is definitely great, but you should have kind of some control around it if you want to implement it in an organized way with some governance around it. So although the import data is flexible, but you might consider doing it in some other ways. So composite mode, DirectQuery, live connection is like the one that is the least flexible because everything should be done in that live connection data source. Which one is more scalable? DirectQuery, you can have like as much as size you want, and considering that you can have composite mode, that means you can basically have a good performance with that as well. Also scalable, but good performance. Import data just by itself without having some DirectQuery tables behind the scene is not that much scalable because you are limited on the size of the model you can handle based on the license you've got for Power BI. The architecture I normally advise is kind of, and this is also including data flows, but if I put the data flow side of it aside, is that you use still the live connection. So your Power BI report is connected live to the dataset, but then the dataset is importing data from somewhere else. So you are kind of using the good thing about both. You are using the governance of the live connection. This means that many of your data visualizers are not going to change your model. You have data modelers to take care of that. Your data model can be either import or it can be that composite model. In that case, then that means you can cover like large set of data. So you can actually combine these together to end up with something that works best for your scenario. The bottom line is that there is no like answer to say this is the best type of connection, this is the worst type of connection. It all depends on the scenario. It all depends on what you are going to implement. I have like a lot of free articles, videos about these, and a Power BI architecture book and a Power BI architecture video course. Go ahead and check these resources on Radacad website and Academy website. Now we can go through questions. I guess the first one is Anand. Using import mode as we have data, both analysis services and other data source for Azure Analysis Services data, is it better to write DAX queries while importing or get data into Power Query and then filter performance implication? Any best practices, Azure Analysis Services, other connection with import? Okay, that was a few questions in one. If you want to build your model in analysis services, basically it's similar to Power BI dataset. You need to, however, have some performance consideration, like what you mentioned. Filter data as much as possible. Don't bring the data that you don't need, because this is at the end of the day, it loads in memory. Smallest amount better. Make sure that you remove your high cardinality columns. In terms of writing your DAX expression, the way that you can write it is really important. You can write DAX expressions that can complicate things. Make sure that you push your calculations that are row by row basis back to the Power Query, because that is the place that they should be implemented. If you can use data flows beside it, that's even better, or any other data transformation technology like Azure Data Factory or anything like that. That's even better because you can do things in the data transformation stage. Then in DAX, you only focus on more dynamic calculations. Don't write static calculations with DAX measures. And many other things around it. Some articles about how to do performance tuning on your dataset. Gina, we already showed that, so that should be good, hopefully, I guess. Aaron, is there a pro cons slide for composite model like others? Did I have that or not? Probably I missed it. Let me just check if I had that. Or maybe I missed that part. So basically, the pros and cons of that, I can tell you this, that the pros is you can have two good things beside each other, the big size, scalable, and the performance, everything good. The cons, I would say, you need a little bit more time to implement it because you have to consider every aggregated table, you have to create it, so the development time would be a little bit more. You have to monitor the way that users are using this, because based on that, you go and create aggregated. You shouldn't just create an aggregated table and leave it there, because that might not be something the user uses. User might use something which you have not created aggregated table, and then as a result, it performs slow. So you have to be in touch with your model, with your users, gather the log information and see how these are all working. So you need to have more interaction with that. I would consider that as the, not a disadvantage, but that as, let's say, something to consider. Any other questions? Gina, no worries, just wanted to understand the relationship works. Great, thank you.
There was a question from Chuy. I'm not sure if that was answered with the link. He was asking if data flow is not considered as a live connection, but dataset is.
Right.
Being both hosted on Power BI service, why only dataset is considered live connection?
So live connection is basically when we connect to analysis services. Data flow is not analysis services. Data flow is using the file system. Data flow stores data in CSV format. When you get data from data flow, it looks like that you are getting data from basically like a CSV file. It's a little bit different though, but it looks like that. With data flow, however, you can have direct query. But then how does it work? Because data flow doesn't support, because CSV file doesn't support direct query. The way that it works is that behind the scene in the compute engine of Power BI, it loads this into a compute engine, and then you connect direct query into that compute engine. That is, let's say, SQL Server now, but it might be something different later on. So that is why it supports import or direct query. I think direct query is limited to a premium account at the moment, but it doesn't support live connection because it's not an analysis services model. It's not a place that you have DAX calculation. It's not a place that you have your data model in it. It's a place that you have your data tables. Consider data warehouse like a normal database. Not exactly like a data warehouse, but a database that you use to store your tables in it. But then you load this into your model. So data flow is like the layer before building the data model. I hope that helped understanding that. Live connection equal analysis services. Yep, that is absolutely right.
There is another question from Wilson. Can it be used with Azure NoSQL source like Cosmo or Azure Storage collecting live data from IoT devices?
I don't really know if we have a direct query connection to Cosmos DB or any of those. Definitely import data is an option for any data source, regardless of whatever it is. Direct query might be available. And if direct query is available, then that means the composite model would be available as well. So any data sources you think, is it possible or not, import data most likely is possible. Okay, any other questions?
I don't see any. Guys, if anyone wants to unmute or raise a hand, please do.
And if you have any questions later on, reach out to me. Yep, go on. There was a question. Yes, no?
Hey,
Maybe
Reza, I have a question.
Sure.
So on the live connection, like say we're using a Power BI data set.
Right.
And we write some DAX measures, you know, within the report. And then we publish that report back up to Power BI service. So that is does that publish the data set and the report, or just the report when it gets published back to Power BI service?
So that is when it gets a little bit tricky. Like when you have a live connection with your Power BI report, you create kind of like some calculations, like that report level measure, and publish it. Then that has like a little model itself, right? A model that is on top of that model with some like additional things in it, right?
Yep.
Does it mean that you should be then using that model, like a second layer on top of that, doing some visualization? I would say no, because as soon as you start doing it, then you end up with like silos and many other things that might cause many other issues. I would say if you are going to use probably a calculation created in one report in other reports, better to create it in that model.
Okay, got it. So the Power BI data sets, if you decide to use them like in a live connection, well, if you're using them, it is a live connection, I guess. But the idea is behind them is that should be considered like a curated data set that everybody should use, and that all that design and modeling should be taken care of within that data set.
Yes. Yeah,
Okay.
it's okay to create like few calculations for some self-service purposes for just that report only, but not for, let's say, spreading it out in other reports. It's best to consider that data set as, let's say, your gold data set, and everything else built on top of that.
Okay, got it. Yeah, thanks a lot. And thanks for the presentation. Really
Welcome.
good. Thank you.
Welcome.
There is another question from Ankit. What are your thoughts when we connect to JSON dataset?
JSON dataset. JSON is like a normal text file system. So we can only import data at the moment. But that works like a normal text file, and we have the, sorry about my dog. Okay, sorry about that. It's a big dog, you know. So in terms of JSON, the performance would be fine because it is importing data. You just have like the refresh time, but in terms of the analyzing data, everything works fine, and you would have a good report performance on it. Okay, if you have any questions later on, feel free to reach out to me in our website. If you have any questions, let me know. That might lead up to another blog post later on. I'll be more than happy to have a look at that. And thank you for attending. Thank you, Cecilia, for the opportunity and organizing this.
Thank you so much, Reza, and thank you, everybody.
Thank you. Cheers.